All right, so I wanted to talk to you about this recent um, uh, study that was done looking at the connection between food allergies, environmental allergies, drug allergies, and MS progression. Okay, so what they did was I think they took about almost 1,400 people, and these people either had a drug allergy, a food allergy, or environmental allergy, and they also had a control group where these people with MS didn't have any allergies, and they looked to see what their rate of relapses and new lesions on MRI was. What they found was that those who had food allergies were more likely to have relapses, and they were more likely to have lesions in the brain that we could detect with contrast, the gadolinium that we all get when we go and get our annual MRIs. And this was significantly higher when compared to the MS patients with no allergies. So clearly something's going on. When people report food allergies, there's something happening at the level of the immune system that's impacting demyelination. And so this is an important concept to keep in mind. In fact, I think their rate of having these progressions in MS was about 1.38 times higher, which was statistically significant. So let's just kind of do a quick background. There are many different kinds of food reactions, and not all of them involve the immune system. There's anaphylaxis. Those of you who may have this know it, and you know what foods are involved. Anaphylaxis. I personally do. There are about 4 nuts that I cannot go near because within 5 seconds of contacting it, whether someone kisses me on the face or I accidentally eat it, I feel like I'm going to die. It's like 5 seconds. It's not delayed at all. And it is severe. You will feel ill. Your GI tract will go crazy from above, from below. You'll have abdominal pain and cramping. And you can also have a lot of airway swelling. This is a reaction of your immune system pouring out IgE antibodies. It is quick and the symptoms are severe. So people with anaphylaxis know it. There's no question. There are food intolerances. Some of you here might actually be lactose intolerant. Many of us, as we become adults, lose our enzyme that helps us break down lactase that's found in dairy products. So because we lack that enzyme that we haven't, used, and so it just sort of becomes less prominent, we don't process dairy products well. This is not a reaction that's mediated by the immune system. It's an enzyme problem. So food intolerances, just the immune system is not involved. What we are going to focus on is food sensitivities. Unlike anaphylaxis that involves IgE antibodies, food sensitivities involve IgG antibodies. These antibodies are slow to increase in the body, and the symptoms they cause are subtle. And so they're much harder to detect. You don't get sick within 5 or 10 minutes or even an hour. It might take longer. It might take half a day, 2 days. And the symptoms might just be a little rash, a little abdominal pain. Maybe something happens to your skin. Maybe your mood's a little off. So these are hard to pick up. And this is what we're after because it's one of the factors that drives the immune system to stay active and to create inflammation and to constantly react to things that it comes in contact with. So I want to talk about this concept of immune tolerance. It is really central to understanding autoimmunity. So your gut is tasked with bringing in food for nutrients. It's also tasked with keeping out dangerous things like viruses and bacteria. The immune system and the gut are intricately connected. As soon as something crosses the lining of your gut layer, it's going to contact the immune system. And that's really important because that's your second checkpoint to make sure that the thing that entered is truly safe to enter. So it's your second layer of protection. And so the gut and the immune system are always constantly communicating with each other. Immune tolerance is something that your immune system has to learn, and it starts probably in utero when your mom was pregnant with you. As our immune system gets exposed to different things, it learns what to attack and what to leave alone. And this is really important, right? So you want to attack viruses, bacteria, worms, parasites, maybe even toxins or molecules that are man-made and not really natural. But you do want to leave alone food and your own tissues, your body. Because if you start attacking food by making antibodies to it and then attacking it, we call that a food sensitivity. If you attack your own tissues because you have now developed tissues to your joints or to your myelin, that's called an autoimmune disease. And so the immune system needs to learn what to attack and what to leave alone. And guess what actually helps it do that? Early life exposure to a lot of ordinary bugs that don't make us sick, that don't cause disease. This is why we don't want to live in sterile environments. This is why it's good for kids to play with dirt. And so this is an important educational period, and it actually continues throughout life. Also, our gut microbiome, those good bugs that live in our large intestine play a role in creating immune tolerance, tolerant to not attacking food and our own tissues. Now, there can be loss of tolerance. For whatever reason, your immune system gets confused and it starts making antibodies to food and to your tissues. And now you are left with food reactions and autoimmune diseases. And this is partly why people with autoimmune diseases also have higher rates of food reactions. It's the same foundational imbalance. Your immune system's forgotten the rules. It's forgotten what to attack and what to leave alone. And so it's not a big jump to go from attacking food to attacking your own tissues. So now let's talk about leaky gut. People love talking about leaky gut. It's like a buzzword you'll hear if you are anywhere within holistic, integrative, functional medicine. I want to show you what leaky gut looks in this artist's rendition. We can actually visualize this under very powerful microscopes, but it's not yet in clinical practice. So imagine that the top white area is the tube, the hollow tube inside your GI tract from the mouth to the anus. And this is where food travels and it gets digested, and what needs to be absorbed is absorbed, and the rest comes out the other end. So as food travels through this lumen of your GI tract, it's going to come in contact with the small intestine. Right after moving out of the stomach, it goes into the small intestine. There are a single layer of cells that line this tube that is your GI tract. And you have these little finger-like projections called villi. And on these villi are little receptors. And they're basically just little feelers that your cells put out to see what's coming through. And if the shape fits, it'll grab that thing, whether it's food or bacteria or whatever, and it'll pull it into the cell. So if something wants to enter the small intestine, it has to bind one of these fingers, go through the cell, and then hit the immune system here, which is that brown line, before going into the bloodstream. That's how it normally should work in a healthy gut. And if you notice, these cells are nicely adhered to each other with these proteins called zonulin and some other proteins there that we can actually measure in blood tests. And Dr. Roberta will tell us more about that in a little bit here. So normal scenario, all the cells are nicely adhered to each other. If something wants to enter, it has to go through the cell, get past the immune system and into blood. Now look at this scenario to the right where the proteins have broken down. There are spaces between the cells. They're no longer touching each other. And unwanted things, partially undigested food, man-made toxins, or even toxins made by bacteria, for example, or the bacteria viruses themselves, now can bypass that first step of binding the villi before they enter. And so now they're leaking in, you have a leaky situation, and now you hit the immune system, which is your second checkpoint. You can imagine if these cells are not tightly adhered to each other, that lots of things are going to get through, and the immune system is going to start seeing a lot of things coming through, which feels like a danger signal to the immune system. It's not supposed to see so many things. And so the immune system goes, something's wrong. I'm sensing danger. Let me turn on my defenses, turn on inflammation, make antibodies so that I can protect this person, right? So this is what leaky gut looks like. And what we would want to do is to go back to this scenario. And it's very much possible by doing a gut protocol that we'll talk about at the end. So just to summarize, leaky gut is a breakdown of the small intestinal lining. So you have this situation to the right. You've lost your ability to regulate what enters the body. Things that need to enter, like nutrients, may not enter, and things that are unwanted can now enter. And your immune system gets overstimulated and revs up its defense mechanisms.